So now let's see what kind of questions have appeared and what kind of questions are expected in the JEE mains examination from this section. So here's the first question for you. The density of a material in SI unit is given to us in a different unit where the unit of length is taken as 25 centimeter and the unit of mass is taken as 50 grams. What is the numerical value of density? So what do we have? We have two different types of systems. One is the SI unit and the other is a different unit. Okay, let's call it a different unit. In the SI unit, the value of density is 128. So density is equal to 128. Density is mass per unit volume. So in SI units, its unit is going to be kg per meter cube. Mass per unit volume. We've taken standard units of everything. So they're asking what is in this other unit, in this other system, this one, what is the value of density? Now we can do this through dimensional analysis, but that we haven't studied till now. We can do it without that also. So let's try that method. We have to find what is the value of density here. And we know what are the standard units of length and mass. So we call this density 2, this as density 1. See, it's the same object. So rho 1 will be equal to rho 2. Density 1 or density in the SI unit, we know it's 128. That's the numerical value if kg and meter are taken as standard units of mass and length respectively. But in the new system, the unit of mass is, see it's written here, it's 50 grams. 50 grams. And the unit of length is 25 centimeters. So 25 centimeters whole cube. So what will be this value? X. That's what is asked. We just have to calculate. See, now you just solve it. Okay, so we'll do that quickly and see what value we're getting. So the value of x is evident from this. The value of x is 128 multiplied by 20 divided by 4 cube. See, this cube is also there, no? So 128 times 20 upon 16 into 4. This is what is x. Let's calculate it quickly. From here, you'll get x is equal to 40. This will go 8 times, so 40. Yeah. All right. Let's see a different kind of question which has also appeared in JEE Mains. This has appeared in the year 2013. So, a metal sample carrying a current along the x-axis with density J. The current is moving in this direction. And instead of current density has been given to us. Well, current density is equal to current per unit area of cross section. Yeah. And then there is a magnetic field along the z-axis. Okay, Bz is present and it's along the z-axis, so along this direction if this is the y-axis. And then there is an electric field also. Now the question says that the electric field developed is directly proportional to Jx and Bz. So this is what the question says, that the electric field Ey is proportional to Jx and Bz. If we have to remove the proportionality sign, we'll have to put in an equal to sign and introduce a constant of proportionality k. So this is what we have. This tells me that k can be expressed as Ey upon Jx Bz. So essentially what we have to do is find the individual units of electric field, magnetic field and current density, substitute it here and find the unit of K. That's what we have to do. Let's do that quickly. What is the unit of electric field? How do we find that? There are multiple ways to find that. We'll just pick one. So force is expressed as electric field times the charge, force on a charge. So we'll use this formula to find the unit of electric field. We'll also use the formula QVB to find the unit of magnetic field. I've chosen these two specific formulae so that I have some common terms in both. Okay, that will be, let me just shift this way. Yeah, so it will be easier for us to cancel these out. So F equal to EQ and F is equal to QVB. And the unit of J, we already know, ampere upon meter square. So now let's substitute and see what unit of K is coming out to be. That means Newton per coulomb. See, force upon charge, so Newton per coulomb, upon Jx, so the unit of that is ampere upon meter square, so ampere upon meter square, multiplied by the unit of Bz. The unit of Bz, as you can see from this side, it's Newton per coulomb per unit of velocity, which is meter per second. So I'll just write this. It's Newton per coulomb divided by meter per second. Yeah. This part and this part is going to get cancelled. This two will cancel. So essentially we'll have meter square upon ampere here, and this gets multiplied by meter per second. So we have something like meter cube per ampere second. This is our answer. This is the unit of K, meter cube per ampere second, which is option number B. Now we'll move on to the next segment where we're going to study about dimensions and dimensional formulae in the next video. Thank you so much.